Welcome to The Real Life Buyer. Whether you are buying for yourself or your business, here you will find tips, techniques and knowledge to support your journey to buying smart. Interviewing business owners and technical experts to give you information and guidance before parting with your money. Save money, time and get what you want when you want it. Now introducing The Real Life Buyer, Dave Barr.
Hello and welcome to The Real Life Buyer. In this episode, I'm very pleased to introduce you to Mr. Adrian Williams, owner of Solar Technology International Limited, based in Tewkesbury, Gloucestershire, and now celebrating its 20th year of business. With the increased focus of climate change, the need for green energy has never been greater. Being able to generate electricity for your home and business is becoming once again at the forefront of people's minds, particularly if any excess energy can be rechanneled and sold back to the national grid. Solar Technology International not only produces solar panels for both domestic and commercial applications, but also produces other products for those with a mobile life. This encompasses applications for motorhome owners right through to the Rambler. I'll hand over to Adrian to explain more about the company and the range of products produced. So, hello, Adrian, and welcome to the show.
Hello, Dave, and thank you very much for inviting me on. So, solar has changed, well, quite a lot in 20 years, although the technology itself is pretty much where it was. It has become more efficient, but efficiency in solar terms just means you can get a lot more power into a smaller package. So, solar panels are about 30% smaller, or you can get 30% more power in the same size. And this is very useful, certainly when there's a limited space, as often there is in many of the applications that you mentioned. So whether it's the portable power pack system, we have systems that literally are the size of a pack of playing cards, to sort of medium power sort of base camp units, if you like, which don't take up an awful lot more space, right up to the solar panels you may see on the roof of a house. The typical sort of 14 solar panels on the roof of a house is, roughly speaking, not far short of double the power that it would have been 20 years ago. The other key element in the solar world is the cost reduction. Around about 2010, 2011, the cost of silicon feedstock dropped dramatically. And this, of course, meant that the accessibility to most people, financially speaking, for solar became incredibly viable. And that trend, although has sort of ceased to be as dramatic as it was, certainly is still going down, and the viability of solar is becoming more and more prevalent.
Okay, and you said you do quite a range of projects. Are they all produced in your own factory?
So all the products that are effectively a Solar Technology International product are all designed here in the UK. They're all made in Asia. We use a mixture of our own factory and contract manufacturers. But in essence, everything is designed in accordance with our specifications, quality controlled in accordance with our specifications. And of course, they're made exclusively for us because we own the tooling and the design rights to those products.
Okay, so if we were going to take a virtual walk through your facility where you are now, what would we see?
Well, if you walked into the office, it would be an office like any other office, a number of individual rooms, a few large rooms where a number of people work. And here we have everything from the quality control to ordering, to logistics, to operations, sales order processing, working with suppliers, accounts, and of course myself. And then if we were downstairs, we would have our warehouse. So you would see a lot of rows of high bay pallet racking with our products all stacked up. right to the ceiling. And as we go through the warehouse toward the back of the warehouse, we have a separate large room which we use partially for packing and dispatch and partially for product testing and quality control. Above that room, there's a little bit more storage where all of our packaging materials live.
Okay. And how many people are on your site?
So we have 14 people, not all on our site. We have some field sales engineers. One based in Blackpool, covering the north of the country, one based in Stratford-on-Avon that generally covers the east side, and then another down in Devon who covers the south and southwest.
Okay. So when I've been working my way through your products, I'm particularly interested in solar panels, the type that go on domestic property. And I noticed there are some different types. Perhaps you could explain to the listeners the difference between in-roof, on-roof and solar tiled systems.
Yes, certainly. So the conventional solar panel is called on roof. This is what most of us are used to have been seeing. They effectively, for want of a better word, float above the roof tiles. They're held onto the roof tiles by stainless steel hooks, which effectively are anchored to the rafters, the timber rafters of the house. And then obviously the tiles are relayed over those hooks to maintain the waterproof integrity of the roof. So effectively the solar panel sits about 3 centimeters to 5 above the roof line. They're the easiest to fit, and obviously from a retrofitting point of view, i.e. the house is already up and built, by far the lowest cost method of getting solar onto a property. In-roof effectively does away with the conventional stainless steel and aluminium roof structure, mounting structure, and instead it basically lays the solar panels into a tray which flush fits onto the roof. Now, these are typically fitted on a new build because they are more expensive than on roof. And part of the cost-saving offset is, of course, to reduce the number of tiles needed on that house. Of course, if you were retrofitting in roof, which certainly we have customers that request us to do that, then of course we have to remove those tiles, and the cost saving is effectively not there for that. So in roof looks smarter, it's flush with the tile, but from a distance you'd have to have a fairly keen eye to tell the difference between on roof and in roof, because ultimately the panels are the same. And then solar tile is, as the name suggests, instead of using a concrete or clay or slate tile, there is a man-made substrate with a solar cell laid on top of each tile. This is then, of course, laid on the roof in a similar way that a conventional tile was, and it effectively replaces that tile. So the tiles butt up exactly with the tile that would be used on the property, in other words, on the edge of the roof. And of course, the idea is to try and colour match the solar tiles so that it suits the roof. Practically speaking, it's only ever going to do that if the roof tile is slate. So you've kind of got this fairly uniform dark black colour. Again, it's one of those propositions where often as not, it's been dictated that the owner has to have that to achieve building regs or planning permission. Where it's in a area of outstanding natural beauty or a conservation zone, there may well be an objection to having conventional on-roof or in-roof solar. It is more expensive, a lot more expensive, most expensive of the three. Technically, it's not without its issues, because ultimately an on-roof and in-roof system has 14 electrical connections, and a tile system has 200 electrical connections. And of course, as we all know, the weak point of any electrical circuit is the connection. So, this isn't to necessarily scare anybody off. The connectors used are industry standard multi-contact connectors. They're very, very reliable. But it has been known that these have failed. And of course, you're multiplying the potential of that happening, obviously, by sort of 8 or 9 by using the tiles compared with the conventional. So it is a considered purchase, and it is something that we've certainly done quite a few systems for, but it's by far the least popular of all the 3 options.
Okay. Thinking of efficiency, I assume the in-roof and on-roof are fairly similar. Do the tiles, are they more efficient at generating energy or less, or is there any difference at all?
Okay, so this is kind of touching on the point that I started our conversation with. Efficiency in solar photovoltaic terms is a slight misnomer. We think of efficiency in normal works of life being generating more energy, being lower cost, being all the things that we actually associate with a refrigerator or a car or any appliance of that sort. But efficiency in solar terms is simply dimension. The higher the efficiency, the smaller the size. So, we could take, for example, a 300 watt solar panel using the very lowest efficiency, effectively a B grade cell. And we could take the same 300 watt panel using a high efficiency cell, the very best you could get, SunPower, they have 22.5% efficiency, and there are higher efficiencies than that. And both of those panels are still going to produce 300 watts per hour. They won't produce any more, they won't produce any less. They will produce exactly the same. The only difference is, of course, your high efficiency panel is going to be a lot smaller. So the question simply is how much power can we squeeze into the smallest space possible? And that is a relevant question for a lot of domestic properties, because, of course, with hip roofs and valleys and whatnot, there may be a key limitation to how much power you can fit on that roof. If somebody were looking at solar from a pure efficiency, i.e., I want to get the most watts on my roof as I can, then we wouldn't be looking at tiles. We wouldn't be looking at in-roof. We'd be looking at on-roof, because by far, the biggest choice of solar panels, for example, on-roof, there are about 160 manufacturers. In-roof, there are 4. Tiles, there are 2. So, your choice is dramatically improved by going for on-roof. That conversation would develop depending on what the customer wanted.
Okay, that's really interesting. Thanks. I believe your own engineers install your rooftop systems in the UK. What training?
Yeah. Sorry, they do. Yes, I was agreeing with you.
Okay, fantastic. Just thinking about the training and competence for those engineers, it's probably quite a demanding role. I certainly wouldn't want to be climbing onto a roof, making electrical connections and such. I don't like heights particularly. So what kind of training and competence do your engineers need to have to become fully qualified to do the work for you?
Okay, so the fitting of solar panels is probably 80% electrical and 20% roofer. Now, the roofing element, there is no training as such. It is one of those roles that you sort of learn on the job. Of course, it's critical that the guys have working at height training. They're familiar with harnesses and rope systems. They can fully anchor themselves to scaffolding or cableways that are sometimes used more on commercial roofs than domestic. But ultimately, this is a job that is learned through experience and obviously training for the specific safety elements. The electrical side of things, well, if you're installing and commissioning PV systems, you've got to be a fully qualified electrician. There's no shortcut to that. And so, of course, they have to be up to the very latest electrical edition, which I think we're on 18 at the moment. They have to be certified. Obviously, they're assessed every year we use an organization called Alexa that does that certification training. So that's the requirement for the team that physically installs. And then for us as a company, we have to be certified by MCS. MCS stands for the Micro Generation Certification Scheme. It's a kind of government quango sort of, but it's been outsourced. And it was set up in the first instance to ensure a certain degree of quality was supplied by the installers to ensure, obviously, customers' properties weren't damaged by solar. And of course, solar, put up incorrectly is a very dangerous proposition. Your solar array will be generating somewhere in the region of 400 volts DC, which is death, if you get it wrong. It's affecting the roof structure, which of course could lead to significant damages if it's done incorrectly. And we've seen plenty of the evidence of this, where either a fire has been caused on the roof and burnt the tile through, or simply water has got in and effectively damaged the entirety of the upstairs ceiling and a lot of furniture below. So right from the word go, when the MCS feed-in tariff process started in 2010, we sort of had our warranty document sort of created so that it gave our customers the peace of mind that we weren't just liable for the equipment we fitted, we also covered any consequential loss. And I'm pleased to say we've never been called on that warranty, but it is part of who we are and what we do as a business. If one of our people accidentally sticks his foot through the ceiling plasterboard and takes out some expensive furniture or what have you, we are liable for that, and we willingly accept that we are. So the training of the guys from a legal point of view is obviously a given, that's required. For us as a company to comply with MCS, of course, that's a given. We must comply with that. But then we overlay all of that with our own training for our people to make sure that things such as basic courtesy for the building owner, being aware that if it's raining outside, nobody's going to want somebody with big old boots clumping up the stairs. So they're obviously supplied with oversocks to wear, these kind of waterproof things. Mess has to be cleared up at the end of the day, particularly if it's a multi-day job. And of course, when scaffolding is erected, simple things like, the scaffolding poles don't stop people opening a window or opening a door or things like that. That's, and of course, every company will have its own sort of diktat on whether they do or don't do that type of process, but we certainly do.
Okay, that sounds very comprehensive, and I should think an excellent peace of mind for a customer. And if I just inquire a little bit more about the warranty itself, it's obviously that's on product systems and installation. Is that a 5, 10, 15, 20-year warranty? How does that work?
Yep. So this depends on the kit. So we basically put a 10-year warranty on the solar panel, although I believe that's just raised to 12 years. But anyway, pretty decent long time, and that's basically covering the integrity of the solar panel, manufacturing, water ingress, delamination, normal typical process. And then on top of that, there's a 25-year cell warranty. So this, in essence, is a guarantee that by year 20, the solar panel won't be outputting any less than 80% of its new power. So this suggests that the panel itself degrades at a rate of 1% per annum. It doesn't. It's very little in the first few years, and then it sort of starts to taper off after that. But the reality is, I mean, we've got solar panels when we first started out in the field. And, you know, them being, well, when we last tested, they were 19 years old, and they'd only degraded by around about 4.5%. So, you know, the warranty is kind of almost irrelevant, because there's no way the solar panels are going to degrade that fast. So that's the score with the solar panel. The next piece of kit is the inverter. Now that comes with a 5-year warranty, although there is an option to extend that to 10. The roof equipment, so these are the stainless steel brackets, the aluminium rails, they have a 10-year warranty. In fact, all of the electrical equipment, these are the isolator switches, the kilowatt hour meter, they all have a 10-year warranty. The installation labor is covered for 2 years. So this is more to do with what I spoke about earlier regarding consequential loss, because the warranty on all the parts also includes the labor element. So if a solar panel were to fail, you know, in year 9, that wouldn't be a question of us just sending the customer a new solar panel. It would be a question of us turning up with scaffold and a solar panel and fitting that solar panel and removing the failed unit. So yeah, the warranties are not over complex, but certainly, you know, our terms and conditions, we hope, really kind of clearly define what we're liable for, which in the case of the job is pretty much everything.
Yeah, that sounds very comprehensive. So with a 12-year warranty, then obviously the materials are very robust, etc., and they're not likely to corrode. Just curious, what are the main materials of construction for a solar panel?
Okay, well, the process starts with building the cell circuit. So when we started, solar cells were mostly manually soldered. So if you've seen a solar cell, you'll notice there are silver ribbons on the top. These are the electrical buzz bars. The cell itself, or the cells, will be laid out on a board, and then somebody would go along and they'd be soldering each buzz bar to the cell. So you'd be basically creating this sort of skeleton, if you like, of the solar cell circuit. Well, nowadays this is all robotically done, and much to the better. It obviously reduces costs massively, but it also completely removes the potential for finger marks and over heavy-handedness and potential for cracks in the solar panel. So you've got your cell circuit that then effectively moves forward in the production process, and it's top and bottomed with an EVA. This is a clear film that sandwiches between the underside of the solar panel and the glass at the top, and it's there to protect the solar cell, and it's also there to effectively not quite melt, but effectively vacuum form around the cell circuit during the lamination process. So then the rear of the solar panel has a typically white, I mean it can be black depending on the color of the solar panel. It's a Tedlar, a DuPont Tedlar material, which effectively is a I think it's a polyurethane, and it's essentially a weather resistant coating for the backside of the panel. And then finally the solar glass is laid on top of that sandwich, and solar glass is really quite a specialist thing. Most of our commercial glass, in fact all of our commercial glass, has a high degree of UV filtration in it. to obviously stop our curtains getting faded and so on. So, well, this is the last thing you want with a solar glass. Of course, you want as much UV radiation penetrating the surface as you can. So removing these materials, which effectively is iron, it's iron that's impregnated into commercial glass. So removing that weakens the glass quite significantly. So to make sure we compensate, solar glass is made in typically 3.5 millimeter thickness, which is a lot thicker than our commercial glass. But it's necessary because these systems are designed to withstand 2-inch hailstones fired at the glass surface at 60 miles an hour. Mm. So once the glass is on top, it then goes into the laminator. So the laminator puts heat and pressure on that sandwich and forms it into one complete laminate structure. So from there, the solar panel is then flipped over, so its cell surface is facing down. The junction box is fitted. So basically, you've got your 2 terminating silver ribbons from your cell protruding out the back of the Tedlar white surface. The junction box is glued around the outside, and those ribbons are then connected to the main positive and negative terminals within the junction box. And this is, of course, where your cable feeds onto. So with the junction box fitted, sometimes cable fitted, sometimes not, the entire product then moves on to framing. And again, the framing process in some factories is fully automated, in some it's semi-automated, but essentially the solar profiles, which are hard anodized aluminium, are then basically bonded onto the panel edge, and sort of dog-tooth connectors are used to go inside the panel apertures, the framing apertures that basically hold the mitered corners neatly together. So that's your finished panel, and then they go off for testing, and testing is done 2 ways. The first is a flash test. So a solar panel is measured in accordance to standard test conditions. These are a set of criteria that are a standard around the world. And all solar panels should be supplied with an electrical readout that confirms the barcode of the solar panel complies with the electrical data, which will prove its conformity. From there, we move on to electroluminescence testing, EL testing. An EL is the equivalent. Now, I mentioned back in the day when solar panels were soldered, the electrical ribbons were soldered. That actually couldn't happen anymore, simply because solar cells are now laser sliced. They used to be mechanically cut, they're now laser sliced. They're very, very thin, and microns thin. So thin, in fact, if you were to hold one by the corner, it would break under its own weight. So the potential for a cell to be cracked during the lamination process is low, but not impossible. And a cracked cell is a serious business for a solar panel because, of course, during their normal life cycle, they will be expanded during the daytime when there's sunshine on them and they're heated up. And of course, they'll contract at nighttime when they're cooler. And eventually, if you have a cracked cell, whilst it works in the first place, after successive expansion and contraction processes, it simply will expand and not contract. Then you've got an open circuit and you've got a dead solar panel. So vital that any completed solar panels with a crack are sort of fished out quick and basically quarantined and scrapped. So the electroluminescence tester shows exactly if you've got a crack in the solar cell. And we still have around about 8% of failed panels, and our plants are some of the most modern in the world. Not every manufacturer does this, so it's more than likely that there are a lot out there that are blissfully unaware of the fact that their panels have got a time bomb fitted within them. But not us. We ensure that every single panel has this EL testing, And of course, the photograph that shows the test is then married up to the barcode. So when we receive our product, we have the full test data showing the flash test, the electrical test, and also the EL test.
All right, it's very comprehensive. Thank you for that. It's an interesting process, but obviously, I should say, very complex as well. Lots of opportunity for issues perhaps to arise. So it's good to hear how robust you have your systems. Just thinking about a three-bedroom typical property, detached house, can you give a rough idea of what a typical, let's say, on-roof system would cost for that size of property?
Sure. Well, I suppose the system size would probably be 4 kilowatts. 4 kilowatts is without doubt the most popular size, and it seems to fit the bill for an awful lot of properties. The cost of that type of system to supply and fit would be anywhere between sort of £4,000 and £5,000. There are some variables, obviously, hence the spread. But that type of system, assuming it's not heavily shaded or facing north or anything like that, would typically be generating 3,500 kilowatts per annum. And assuming that somebody were to use all of that, let me just get my calculator. And assuming that somebody pays about 17 pence for their unit of electricity, it would save them £595 per year. But of course, it's very unlikely that anybody could use all the power generated, because obviously there are going to be times when we're on holiday. There are going to be times in the height of summer when the system is going crazy and you simply can't use that much power. But our job is to understand the power demand of the customer and to match the solar system in accordance with how much they can use. Because yes, you can export your power if you've got a smart meter, and your electricity supplier will pay you for that, but they'll only pay you around about 5 pence. So you're basically selling electricity at 5 pence and you're buying it back at 17 pence. So it's far better to understand that you will certainly be exporting. There's no way you can't export unless you've got battery storage, and therefore limit the system size that matches with the user's demand profile. So as I say, we spend a lot of time understanding that so that we can offer a system size that gives best value for money.
Continue. Looking at an installation, no doubt you need an engineer to do an assessment of the property. Are there particular factors that suggest this would be a successful installation? And are there other factors that would suggest it may not be appropriate for that type of property? What kind of evaluation is undertaken by the engineer?
Yeah, well, this is something that actually is more about our interests to get right than the customers, because ultimately, if we do the job and then there are all manner of follow-on consequences, we're liable for that. So it is without doubt not a fit-all, and when we do the survey, we are taking careful details of the roof structure, and we're not structural engineers ourselves, but we use a firm of structural engineers that basically do an assessment on the roof capability, on the wind loading for the area, and this is all from the data that we provide, which is all about roof joist thickness, rafter thickness, spacing between each rafter, the direction of the roof, the height of the building, obviously pictures that we take during the survey. And so, that's something that they will look after for us. Things that we don't need to ask them about really are in very, very old properties where there's no felt batten, where you've basically got the tile is the only membrane between the outside world and the loft. We won't go anywhere near, because obviously we know full well that during the course of the installation, the tiles themselves will have to be disturbed, because we've got to remove them to fit the brackets. And of course, on those type of very old roofs, typically using clay tiles, it's next to impossible to replace them in exactly the same position as they were. And of course, in many instances, the only thing holding those tiles is actually moss, which of course we will had to have removed. So we don't need to ask an engineer for that. We just don't do it. But for all other circumstances, we are getting outside assistance to make sure that we are not creating a huge liability for ourselves.
I see. I also noticed, just thinking of those people who may not be able to afford an installation outright, that you offer a solar leasing facility. Can you explain what that is?
Well, we actually don't anymore. In fact, I'm not sure anybody does in reality. So, solar leasing, or rent a roof, as it was called, was a particular favourite during the feed-in tariff days. So, the feed-in tariff was the sort of incentive program government introduced in 2010, and it basically paid customers a fixed amount of pence per kilowatt generated by the solar system. The rent a roof program effectively meant that installers would go and essentially cover the entire costs of the installation themselves. Homeowners would benefit from the electricity those systems produced, but the solar energy company would keep the feed-in tariff, and they would keep the export tariff. Now, whilst feed-in tariff was in existence, this was a very lucrative way to build a really nice portfolio of investment. But since it ended, that's pretty much come to an end. I'm certainly not aware of that type of proposition on a domestic property. Different, I think, on a ground-mounted proposition, where you've got a field with 5 megawatts of solar panels. That as I say, is a different set of economics. But the downside that some rent-a-roof customers are now facing is, of course, there were a fairly strict set of terms and conditions to these rental agreements, if you want, so that if the homeowner needed to sell, of course, the new homeowner would have to accept those terms and responsibilities. And of course, if the new homeowner didn't like solar panels, or wanted them upgraded or changed or whatever, they simply couldn't, unless they paid the solar energy company a very fat exit fee. There have been other issues with regards to serviceability. The homeowner is responsible for the system performing, and if it doesn't, then there have been occasions where people have got very badly sort of fined for something that really wasn't their fault. So yeah, I mean, it was a good way to get affordability for those that couldn't into using green energy. But it's something that always concerned us, as what happens if. And of course, over this period of time, there have been lots of ifs, and it has put people in a very tricky position.
Okay, thank you for explaining that. Think about best practice. Your customers bought a system. They obviously want to make sure it's maintained as well as it can be. Are there certain things they should do to ensure the integrity and life of the system to get the optimum performance?
Well, the most obvious one is having the solar panels cleaned. Dust and particulates from the atmosphere, particularly if it's in an urban zone, do sort of sit and accumulate on the surface of the glass. And there have been multiple studies done that show that a dirty solar panel can be losing anything up to 5% of its yield. And this is significant. If it continues year after year after year, and the customer doesn't necessarily notice their yield is going down, then this really affects the performance and their return on their investment. So having the panels cleaned every couple of years, once every couple of years, is more than adequate. And most window cleaners can do it from the ground with extended wands. There are specialist solar panel cleaners out there, and they would do it too. But it's nothing more than sort of soapy water and a sponge needed for the job. In terms of the electrical side of it, there isn't anything that a homeowner should think about DIYing, because, they put themselves in grave risk if they get this wrong. But it is sensible to get their systems serviced by an MCS qualified company once every 3 to 5 years. We provide that service as well. And the typical thing that we would do is to check the integrity of all the wiring. We'd check with our high-level cameras, we'd check the solar array to make sure there was no visual issues going on in terms of crazing, cracking, potential warping of the frame. We would be checking all the electricals inside, typically connected to the inverter, and making sure there was good airflow around the inverter. We'd be looking at the cable, then the AC cable running down to the connection meter, again, to make sure that was good and solid. We'd make sure the isolator switches, so there's a AC and DC mechanical isolator switches, we'd make sure those were functioning. And then we'd look at the yield of the system. We'd look at when it was installed. Whether we installed it or not is irrelevant. We'd calculate theoretically what the system should have generated during the time, and then we'd see what it actually has generated. And of course, if there's a big disparity, then there can be one of a few reasons. Number one, the installer rather over-egged the potential of what it could do, or there's been an issue that may have been subsequently resolved, or there's an issue that remains. And somewhere along the line, it's our job to try and identify which one of those three options it is, because we're obligated, once we do a service, to effectively clearly say the system is working, or it's not working, or it's not working as well as it could, and these are the reasons why, and this is our quote for putting it right. Now, whether the homeowner chooses to act on that with us or somebody else is down to them, but at least we've given them all the information so that they can make that sort of informed choice.
Good. That's very, very good, thorough advice there. Thanks. Now, something it's affecting us all right now, COVID-19. It must have affected your business to some degree. How have you managed, pivoted and adapted to maintain supply to your customers?
Yes, it really has affected us. In April of this year, our revenues dropped by 80%. May 50%, and then from June onward, we've been running about 125% on a year-to-date, month-by-month basis. And whilst we can't really take any blame for the loss of revenue in the early part of the year, we also can't really take any credit for the increase in revenue, because where solar installations have necessarily been quite low, of course, people are nervous about having a stranger in their home, and we can understand that. We're probably doing more commercial work than domestic at the moment, but there are signs that the domestic market is coming back. But what's kept us going and going very well are our products for off-grid solar. One of our big market channels for off-grid solar panels are the marine and caravan and motorhome sector. And of course, these areas have seen an absolute boom over the summer months. mainly because, of course, people can't fly or don't want to fly. Staying in a hotel, even in the UK, not necessarily everybody's kind of cup of tea. And from a safety point of view, they wanted to make sure they weren't necessarily exposing themselves to infection. So the caravan and motorhome and camper van industries have seen just the most incredible lift. And we make solar panels for most of the caravan and motorhome manufacturers and boat builders and so on. So their sort of fortune has been our fortune in that regard. They've kind of dragged us along with them. And then, there are strange other things. We have a brand called Hubi, which is a small scale power and lighting system. And these are used in things like stable blocks and workshops, in summer houses, in sort of glamping structures, family camping, that type of thing. And one market that's really spiked over this sort of summer, autumn period has been people buying these lighting systems for their summer house and their shed. And in fact, there was a report I saw about a month ago that said the shed was the current must-have home accessory. We make these kits and sell them mostly through sort of shed manufacturers and retailers. And of course, they've long offered our product as an option, but this year has seen a real uptake. So we're probably supplying maybe 30 of those kits a day, every single day, to them, to their customers. And it's been a very, very high growth. And I suppose this again is relative to the fact that people have had a lot of time at home. Maybe they've been working from home. Maybe they want to position their office in their summer house to kind of have some quiet time. So this has been an area that's been very significant for us. So this is kind of by and large the reason we've kind of weathered the storm quite well. Will we actually cover the losses we made in the early part of the year? Well, time will tell.
Okay. Obviously, the next big storm, so to say, coming up is Brexit. How do you feel that will impact your business?
Well, I can't honestly say I've no idea. I don't think anybody has any idea because obviously we don't know what the rules are going to be. But all of our manufacturing is done in Asia. So, of course, import duty, customs clearance is a factor for us. So I don't see there's any additional burden there. Of course, it does mean that the import process is going to be slower. Everybody importing from Europe is, of course, going to have to go through the same process. So customs clearance and delays at ports, I think, are going to be a given. But the reality is it only means adapting to your supply chain flow by adding a couple of days into the lead-in time than would ordinarily be the case. From an export point of view, we certainly export a lot of materials to Europe, and we've already got in place various export codes and approvals for going to the countries we sell to. And of course, customs clearance from export, like import, really is done mostly on an electronic basis. So we work with a number of forwarders who have systems in place to be able to process those customs documentations well in advance of us physically shipping them. So I think there's probably going to be a bit of a bump in the early months whilst systems are tested. But I think by March the process will be effectively the same as it is at the moment, maybe with, as I say, an extra day or two needed for arrivals, and inevitably a little bit more cost in terms of paperwork. I think the competitive nature of the UK importing from Europe isn't going to be massively affected. And as I say, it doesn't really impact from us because we don't import from Europe. But I think the wider industries that do I sort of seem to think that there's going to be a balance done between ourselves and the EU, whether there's a deal or a no deal, so that effectively both sides are going to have to pay some, but a small sum, because ultimately, we're not in an economic cycle that can really afford to take any form of inflation, certainly governmental imposed inflation by import duties. So coming up with a sort of an agreed duty format, I think is an almost certainty. And therein is what I stand to be corrected on in January. But I do think the two sides will inevitably conclude something that works from a balanced point of view.
Great, yeah. I fully understand where you're going from there. Do you feel that you're as well informed as you can be about Brexit, or do you think there's other things that could be done?
Well, I don't think anybody can be more or less informed. In reality, there's plenty of information out there, and ultimately, it's down to anybody affected by the potential changes to either be provided with professional advice or to read up themselves on it. But in the end, it's all sort of it's all guesswork, because ultimately we don't know what the deal is going to be or not. And until we have clarity on that, then we're looking at lots of scenarios, most of which will never happen.
Yeah, absolutely. Very much a developing situation. Absolutely. Very conscious of the time. Thank you very much so far. One last question. If we were to fast forward in time to the next 10 or 20 years, how do you foresee solar power generation developing?
Well, I don't necessarily think there are going to be any major leap forwards in solar technology per se. You never know. We are some way downstream of the boffins in white coats who are developing all the new swish tech. So, hey, there might be something next year that completely revolutionizes. You can get 4 kilowatts from the size of a postage stamp. But in all probability, it's not going to happen. And solar is no doubt going to improve in efficiency, but in very small incremental sums and nothing major that we'd necessarily notice. However, what I have long since thought is that what's really benefited from solar is actually the reduction in the power consumption of the appliances that we use, the solar powers. If you take the humble light bulb, when we started, our lighting kits had a 60-watt light bulb. It was a filament light bulb. It was called 60 watts because it consumed 60 watts per hour. 8 years ago, the compact fluorescent bulb came out. For the same level of lumen output, we're now only consuming 11 watts. And now today, for the same level of lumen output with an LED, we're consuming 3 watts. And this is sort of mirrored throughout all of our appliances, whether it's televisions and refrigeration, computing, hi-fi, everything, not everything, but most things we use in the home have seen some dramatic reductions in their energy consumption. Now, what's also true is that a lot of appliances still operate on a DC current. Television is a perfect example, computing a perfect example. They need a power adapter to enable them to plug into the mains. Now, in that process, of course, efficiencies are lost. Wouldn't it be better if our homes had a DC ring main as well as an AC ring main, where we could run certain things from each? So, you'd be running all the household lighting from the DC ring main, your plugins for your television and your computers, potentially your refrigeration, and then you're leaving your AC ring main for the heavy duty appliances, which will be for the heating element, for cookers, for areas where you're pulling serious kilowatt power. This would have a number of benefits. Number one, of course, it makes your efficient products even more efficient because there's no electrical losses. Number two, it means that a solar and battery storage system could be completely off-grid. So all it's doing is powering your house in your DC ring main. And secondly, it means that in the event of future power shortages and power cuts, you've got an independent power source running through the home that keeps you going even if power is off for a few days. And so the notion of having this separated DC ring main, I think has got some strong legs. We do a lot of work with a number of housing developers, and we've had sort of exploratory conversations with some of those, and I don't expect this to be a fix you see coming in the next 4 or 5 years, but I do think within a 10-year time frame there will be a lot. And what you may or may not know is that a lot of new houses are now being built without a gas main. They're all electric, which of course further sort of, if you like, plays into this notion of part of that house being entirely self-sufficient, which of course it can be. So in some respects, I don't necessarily see the future of solar being anything particularly clever that us in the industry do, more what other people do in terms of that DC ring main and in terms of the continued efficiency gains on appliances that solar can power.
Wow, very interesting. Something I hadn't considered. Thank you for that. And thank you very much, Adrian. The discussions today I found quite fascinating. If a listener would like to learn more about your products and services, where would they find you? What's the best way to make contact with your company?
Well, I suppose the website's the best place to start, and that can be found on www.solartechnology.co.uk, and I'll just say it's technology. There is a company, well, there was a company called Technologies, GIES, they no longer exist, but Solar Technology, OGY at the end.co.uk is us. And our on-grid installation via our PVE brand can be seen there, and all of our off-grid brands can be seen. We can be contacted on hello@solartechnology.co.uk, and of course good old telephone on 01684 774 000.
Brilliant. Well, thank you again very much for your time. It was great talking to you. And obviously, I wish you and your business great success for the future, and hope perhaps we can touch base at a later date as well.
Thank you. Yeah, that'd be great.
Okay, Adrian, take care now and goodbye.
All the best.
Thank you for listening to this podcast. Please subscribe and leave a positive review if you can spare a minute or two. If you would like to contact me, my email address is david@thereallifebuyer.co.uk, or find me at Real Life Buyer on Facebook, Instagram and Twitter, where you're welcome to direct message me. I look forward to you joining me on future episodes. Take care, and remember, save money and buy smart.